Discussing functional programming. We know that in case of mathematics also, if there is a particular function, if you pass any same argument to that function for multiple number of times, then the function will return you the same value. But in case of the procedural programming, if you also pass the same value for multiple number of times, then the procedure may return different values on its execution. So let us go for further detailing on it. So functional programming is style of programming language which uses the concept of mathematical functions. A function in mathematics should always produce the same result on receiving the same argument. So argument means here we are considering as the input argument. And in procedural languages, the flow of the program runs through the procedure, and that is the control of the program is transferred to the called procedure. So whenever a procedure will be called from a certain code, then the control will be transferred to the respective procedure body, and there the procedure will get executed. After completion of the procedure execution, the control will come back to that very line which is just after the line of the calling procedure statement. While control flow is transferred from one procedure to another, the program changes its state. In procedural programming, it is possible for procedure to produce different results when it is called with the same argument, as the problem itself can be in different state while calling it. So that's why it is not mandatory that in case of a procedure, whenever you are passing same arguments for multiple number of times, the procedure will return you the same value, because depending upon the state of your program, the procedure may return different values as outcome. So this is a property as well as a drawback of procedural programming, in which the sequence of or timing of the procedure execution becomes very important, and the outcome of the procedure depends upon the state of the program. Functional programming provides means of computational as mathematical functions, which produces results irrespective of program state. We discussed this one earlier. For the same inputs, if we pass for the multiple number of times, the functional in case of functional programming will be going to get the same output irrespective of the current state of the program, irrespective of the timing. This makes it possible to predict the behavior of the program. Next one is the functional programming uses the following concepts. So what are the concepts they are using? Let us go through them one by one. So first class and high order functions. So these functions have capability to accept another function as argument, or they return other functions as a result. So this is very interesting. A function will take another function name as input argument, and as a result also one function can return another function as the output. So let us discuss this pure function at first. So these functions do not include destructive updates, that is, they do not affect any I/O or memory, and if they are not in use, they can easily be removed without hampering the rest of the program. So here there will be no destructive updates. So it is not actually affecting any memory location or any I/O, and when these pure functions are not getting called, are not getting accessed, are not getting executed, you can easily remove them without disturbing the system. So next one is our recursion. A recursion is a programming technique where a function calls itself repeats the program code in it unless some predefined condition matches. We know that in case of recursive algorithm, there will be some base case. So for certain inputs, outputs will be known to us, and where this recursion will terminate, and recursive algorithm will have a capability to call itself either directly or indirectly. Direct calling means the recursive call will be within the function body itself. Indirect calling means it will be calling another function, that function in turn will be calling the parent one. So recursion is the way of creating loops in functional programming. Next one is the strict evaluation. It is a method of evaluating the expression passed to a function as a argument. Functional programming has two types of evaluation methods. One is the strict, that is the eager. Another one is the non-strict, that is known also as the lazy. Strict evaluation always evaluates the expression before invoking the function. So in case of strict, as it is the eager evaluation, so it will always evaluates the expression before invoking the function. In case of non-strict evaluation, it does not evaluate the function or the respective expression unless it is needed. So when all the input arguments are available to evaluate one function, in case of strict, it will calculate the respective output of the respective expression. And but in case of lazy or non-strict evaluation, the respective expression will not get evaluated even if all its inputs are available. So whenever it will be asked for, then only the evaluation will take place in case of non-strict evaluation. Next one is our lambda calculus. Most functional programming languages use this lambda calculus and as their type systems. So lambda expressions are executed by evaluating them as they occur. In case of lambda calculus, we don't write the respective function name. Depending upon the parameters whatever we have passed, the number of parameters, the parameters types, the respective function will be called itself. So in this way, this is our lambda calculus. So where we are having the anonymous function calling. So common Lisp, Scala, Haskell, and here we are having Erlang and this F hash are some examples of functional programming languages we are going to have here. So here we have discussed what are the different ways in which the functional programming can work and what is the functional programming, how does it differ from the procedural programming. Thanks for watching this discussing programming style. So we know that whenever we develop softwares, I use softwares where multiple coders and developers will be working. So what will happen, I may have to work on a certain code which I haven't developed, which I haven't coded myself. So I might be working with other developed code. So in those cases, if we can maintain a proper programming style, then it will be convenient for us to write the code, to develop the code accordingly. So what are the different do's and don'ts are to be maintained, which we are going to discuss in this session only. So programming style is a set of coding rules followed by all the programmers to write the code, and we are considering the best programming practices. When multiple programmers work on the same software project, they frequently need to work with the same code written by some other developer. So this becomes tedious or at times impossible if all developers do not follow the same standard programming style to code their program. So the coding style should be universal, should be uniform. So an appropriate programming style includes using functions and variable names relevant to the intended task. So that is very important. The variable and the function nomenclature should be done in such a way that it can reflect the purpose of that function or the variable. And using well-placed indentation, commenting, remark for the convenience of the reader and overall presentation of the code. So sometimes we might be working on greenfield projects, and it is very rare in your life you can observe that you are working on a greenfield project. So that means you are starting with a software development from the very scratch of the project. So that is a greenfield. In the most of the cases, we developers always work on the greenfield projects. That means software has been developed already. So now we are going for next version, because some change requests have come. So now we are going for the next version of the software to get developed. In those cases, this variable nomenclature, function nomenclature, indentation, remarking and commenting, documentation of the code is very essential to understand what is the purpose of that code segment under study. Okay, now this makes the program code readable and understandable by all, which in turn makes debugging and error solving easier. Also, proper coding style helps ease the documentation and the respective updations. So what are the coding guidelines? So let me discuss them one by one. So practice of coding style varies with the organization, operating system and language of coding itself. So obviously organization to organization this coding style may vary depending upon the language used or the platform or the operating system whatever you are going to use. So depending that one, the coding style may get changed. The following coding elements may be defined under coding guidelines of an organization. So first one is the naming conventions. So what is the naming convention? This section defines how to name functions, variables, constants and global variables. So where to use the small letter, where to use the capital letter, where to put a space using say underscore, or making the variable names and these particular function names with some proper. So all these things will have some guidelines, some do's and don'ts will be there, so that our naming standard should be generic. Next one is the indenting. This is the space left at the beginning of line, usually 2 to 8 character space or single tab. Next one is the white space. So it is generally omitted at the end of the line. So this a white space should not be used at the end of the line. Indentation should be done. So we should leave some space at the beginning of each and every line to denote that these series of lines are under one block and these series of lines are under another inner block. So indentations are to be maintained. Next one is the operators. So defines the rules of writing mathematical, assignment and logical operators. For example, assignment operator should be equal to, should have the space before and after it, as in case of we have written this one as x space is equal to space 2. In this way the statements we are writing this one. Next one is the control structure. The rules of writing if then else, case switch, while, until and for control flow statements solely and in nested fashion. We know that how to write the say nested for loops. So indentations are to be maintained, and how this block begin and block end marker, sometimes it is curly braces, sometimes we might be using begin and end. So how to maintain them, this is the control structures, how to write them, we should have some generic rule. Next one is the line length and the wrapping. So defines how many characters should be there in one line, mostly a line of 80 characters long, and wrapping defines how a line should be wrapped if it is too long. So whenever a line is having a too long, we should wrap it, otherwise it is line will go beyond the screen boundary. So in one view you cannot read the full line, so it is not comprehensive, it is not easy to read and understand. So in those cases we should check this line length and the wrapping. Let us suppose in a particular program you are writing one SQL query. Okay, so you are writing in this way, select star, you can put enter, you can make the from the next line. So select star from say employee, where employee ID is greater than say 1000 and salary is less than 50,000. So you can break this line into, you can write this particular statement and broken into multiple different lines only to make the query readable. So that is our common practices, so we usually follow that one. Next one, we are having these functions. So this defines how functions should be declared and invoked with and without parameters. Variables, this mentions how variables of different data types are declared and defined. Next one is the comments, is very important. So this is one of the important coding components, as a comment included in the code describe what the code actually does and all other associated descriptions. This section also helps creating help documentation for the other developers. So this commenting and the remarking should be done properly. We can have the line comment, we can have the documentation comment, we can have the block comment. So different types of commenting blocks are available in our programming construct. So in this way, in this particular video, we have discussed what are the different programming styles and what are the do's and don'ts. Thanks for watching this. It's very important because it describes the detailing the information about the software development process. So software documentation is an important part of software process. A well-written document provides a great tool and means of information repository necessary to know about the software process. So that's why to have the detailing about the software process, to keep this one in the repository, this software documentation is required. Software documentation also provides information about how to use the respective product, that means the software product. We know that whenever a software is being developed for a certain purpose, then that particular software will be known as a software product. So also it will help us to know that how to use that respective product. So a well-maintained documentation should involve the following documentation. So what are the different sections are there? So we are having 4 sections. So one is the requirement documentation, software design documentation, we are having the technical documentation and the user documentation. So 4 different types of documentations are there. So let us discuss one by one. So at first I am going for requirement documentation. This documentation works as key tool for software designer, developer and the test team to carry out, because this is our requirement documentation. So at the beginning phase, we always do the communication with the client, with the respective stakeholders in the domain to get the requirement analysis, to gather all these requirements, whatever is going to get implemented in the software. So that's why this documentation works as a key tool for software designer and also for the software developer and the test team to carry out their respective tasks. Because the test team who will be working in the later phase of the software development process, they should be also knowing that what are the requirements and really the software is delivering that requirement with the required precision and all. So that will be tested. So this requirement documentation is also required by the testers along with obviously designers and the developers. This document contains all the functional and the non-functional and behavioral description of the intended software. So in case of functional requirements, we know that so we are having different business processes are to be initiated, the functional requirements will be there, how the transactions will take place, who will have what kind of eligibility in the respective system, how many different types of users will be there. So these are the functional requirements. And in case of non-functional requirements, we are having that how the software, the security will be ensured, how the software is safe, how the software is in interoperability, and what are the infrastructures required, what are the authentication methods we are using. So what is the the deployment details. So all these things are coming under this non-functional. So functional, non-functional and behavioral descriptions of the intended software will be kept in this requirement documentation. Source of this document can be previously stored data about the software, already running software at the client's end, the client's interview, questionnaires and research. So from here we can develop this requirement documentation. Okay. Generally, it is stored in the form of spreadsheet or word processing document with the high-end software management team. This documentation works as foundation for the software to be developed and is majorly used in the verification and the validation phases in the testing. So most test cases are built directly from this requirement documentation. So we have got the detailed idea about this requirement documentation. So now we are going to discuss the software design documentation. So we had the 4 different documentations. So one was the requirement documentation we have discussed. Next we are going to discuss this software design documentation, then we will be having the technical and the user documentation. So these software design documentations contain all the necessary information that are needed to build a software. So what are the different features are to be implemented and what are the different information which are to be required for the building of the software, they will be kept in the software design documentation. So what are the different issues? So let me discuss them into details. So high level software architecture. What is the software architecture we are going to use? The software design details, the data flow diagrams and the database design. So here we can be using multiple UML diagrams. So for this particular software design documentations. These documentation work as a repository for developers to implement the software, and though these documents do not give any detail on how to code the program, they give all necessary information that is required for coding and the respective implementation of the software. So it is a high level one. So obviously the technical documentation will come, which will be very much close to the implementation part and the coding part, but from this particular software design documentation you are getting the idea that high level software architecture, the software design details, the data flow diagrams and respective database design, how the database design will be done. Here we can also consider the year diagrams and so on, schema diagrams may come also here. So this is our part of the software design documentation. So now let us go for the technical documentation. These documentations are maintained by the developers and actual coders, and these documents as a whole represent information about the code. Now we are coming to the code and implementation. While writing the code, the programmers also mention objective of the code, who wrote it, where will it be required, and what it does and how it does, what other resources the code uses, etc. So depending upon what to be implemented, what is the purpose of the code, and what are the other resources it will be required, who wrote it, all this detailing will be kept in this respective technical documentation, because it is very much close to the coding part. The technical documentation increases the understanding between the various programmers working on the same code, and it enhances the reuse capability of the code, and it makes debugging easy and also for the traceable. So this is the documentation which will be used by multiple developers and coders working on the same code. So there are various automated tools available, and some comes with the programming language itself. For example, Java comes with the Java doc tools to generate technical documentation of the code. So we know that in case of Java, there is a very easy way to create the Java documentation using the Java doc tools, with the help of which the documentation against this respective coding can easily be get generated. So it is not like that all the documentations are going to get generated manually. There are different tools and softwares are available with the help of which these documentations can easily be created. So now let us go for the last type of documentation, that is the user documentation. So this documentation is different from all the above explained three categories. So all the previous documentations are maintained to provide the information about the software and its related development process, and obviously with the implementation process. But user documentation explains how the software product should work and how it should be used to get the desired results. So that's why it is called the user documentation. From the user perspective, this documentation will be prepared. This documentation may include software installation procedures, how to guides, user guides, uninstallation method, and special references to get more information like the license, updations, and etc. So from the user's perspective, how to install it, how to use it, how to uninstall it, how to get the respective license updates. So all this detailing will be done, will be kept in this user documentation. So in this way, in this particular video session, we have discussed the software documentation. Thanks for software validation and verification. So it sounds that this validation and verification are very similar, but they are totally different. So let me discuss on them into more details. So at first we are going to discuss software validation. So validation is a process of examining whether or not the software satisfies the user requirements. It is carried out at the end of the SDLC, that is the software development lifecycle, if the software matches the requirements for which it was made and it is validated. That means really the software whatever we are developing is in accordance to the user's requirement. So that is the main theme in case of software validation. So validation ensures the product under development is as per the user requirements or not. So you know that at the very early stage of this SDLC, we usually gathered all the requirements from the users, from the stakeholders in the problem domain, and from there we make a requirement list. So after getting that requirement list, we are having certain other phases, and then we go for the software development and the respective implementation. So in case of software validation, we usually check that this validation ensures the product under development is as per to this user requirement or not. So validation answers the question, are you developing the product which attempts all that user needs from the software? So that question is to be answered in case of validation. So validation emphasizes on user requirements. So now let us discuss software verification. So software verification. So verification is the process of confirming if the software is in accordance with the business requirements or not, and is developed adhering the proper specifications and methodologies. So whether this particular software is in accordance with the respective business requirements or not, and whether you are using the proper specifications and the methodologies. So, verification ensures the product being developed is according to the design specifications. So, whatever we have planned, whatever the design specifications, methodologies we decided, whether that same methodology, same design specifications have been maintained throughout. So, that will be verified in this verification phase. So, verifications answers the question, are we developing this product by firmly following all the design specifications? So, there is a question which will be asked here, and verification concentrates on the design and the system specifications. So, actually you see, in case of software validation, we are concerning with the requirements. In case of software verification, we are concerning with the required specifications. Now, in the next slide, we are going to discuss different terminologies. So, at first we are going to discuss errors. So, what is the error? So, this is the actual coding mistakes made by the developers. In addition, there is a difference in output of software and the desired output, and it is considered as an error. So, the source of the error is the mistakes done by the developer. Now, what is the fault? When error exists, fault occurs. So, a fault, also known as a bug, is a result of an error which can cause system to fail. So, error is the cause and fault is the effect. Next one is the failure. Failure is said to be the inability of the system to perform the desired task, and that is known as a failure. Failure occurs when the fault exists in the system. So, due to errors, the faults will occur, and due to faults, this failure will occur in the system. So, failure means the respective software is failed to perform some activity and the desired task in the system. So, that is known as a failure. Now, here we are having quality control activities. So, I have listed everything into one slide. So, we will be having several videos on most of these particular topics separately, dedicatedly. So, let me just review these diagrams for you. So, quality control deals with this fault avoidance, and fault avoidance can be done in this 3 or 4 different ways. That is a development methodology, configuration management, verification, and the review. With the help of this fault avoidance can be achieved. Next one is the fault detection. So, first technique is the debugging. Debugging can be of 2 types. One is the correctness of the answers getting generated and the respective performances. Now, this fault detection can also be done using testing. So, there is a system testing, component testing, integration testing. So, there are other testing methods that are available. We are having this fault tolerance, we are having the atomic transactions we require, and the modular redundancy should be checked. So, in this way, the quality control activities which is applicable in a software development process has been listed in the single page here. So, in this case, we have discussed what is the software validation and software verification, what are the differences between them, and what is error, what is fault, and what is failure. Thanks for watching this.